So on the stage now, we have Luke from Pulumi. Welcome, Luke.
Hi, great to be here.
Perfect. So Luke's going to walk you through what Pulumi has to offer in this space.
Sounds great. Yes, it's great to be here today. My name is Luke Hoban, CTO at Pulumi. So Pulumi is a new programming model and development platform for the cloud. And so with Pulumi, you can use real code and software engineering practices to define infrastructure in a cloud-native way. So Pulumi lets you work with a variety of different kinds of things in the cloud. The core of Pulumi is working with infrastructure. So you can take any of the kind of infrastructure, VPCs, EC2 instances, IAM roles, anything you might be trying to deploy and manage as part of your application. And you can define that using Pulumi using software. Because it's software, you get many benefits of sort of software engineering. You get type checking, you get tools to help you out, you get components and reuse. Many of the things that are difficult when you're using YAML files, having to copy and paste and manage very large code bases. With Pulumi, though, you can also manage other things. So you can manage Kubernetes. So if you have Kubernetes resources or a Kubernetes cluster that's deployed, you can manage and deploy resources into Kubernetes in just the same way you would deploy into AWS. And in fact, you can use a single programming model to work with both of those at once. And this is really great when you're working with EKS on AWS. And finally, Pulumi lets you work with containers and serverless. So it makes it really easy when you're taking advantage of those AWS primitives where you want to do real simple serverless or serverless with containers with Fargate. You can go ahead and do that in a really simple way without having to do all the boilerplate stuff you might if you were working directly with YAML. So today I'm going to do two quick demos to kind of show 2 points in the spectrum of how you can use Pulumi to work with containers on AWS using both Fargate and EKS. So in the first demo, I'm going to talk about sort of infrastructure and Kubernetes. And so let me dive into that and show you what it's like to actually work with Pulumi. So I'm going to jump right into some code here. So this is a program written using Pulumi. And in Pulumi, you can pick your favorite programming languages. So today we support JavaScript, TypeScript, Go, and Python to describe your infrastructure. In this case, I'm going to be using TypeScript. And I can use that to write a program which describes the infrastructure that I want to exist in my AWS environment. And so in this particular example, you see I'm just saying two things. I'm saying I want an AWS infrastructure network, and I'm saying I want an EKS cluster. So you see here I'm talking at a much higher level of abstraction than we often talk about here. I'm describing things in terms of the kind of ways that we talk about it when we're talking to our colleagues, instead of talking about it in terms of the individual little primitives that I need to deploy if I'm doing this manually. And so what actually happens here is this is a really simple way to stand up an EKS cluster. So this little program that's 20 lines of code or something is going to stand up a full EKS cluster in AWS with a custom VPC associated with it. And I'm going to be able to still control all the things I want to. If I want to describe a different instance type, I can do that. If I want to create a different storage class than the GP2 storage that's the default, I can do that. And if I want to prevent deploying the dashboard into the EKS cluster, I can do that as well here. So I still got configurability, but I get to think about this at a much higher level. And this is important because if you look at kind of what it takes, EKS is a great way to run Kubernetes on AWS. But unfortunately, it is kind of difficult to sort of get from zero to running with EKS. You do have to go through a fair few steps. There's a lot of different pieces of AWS infrastructure you've got to stand up to make that work. And so having these high-level components that makes it really easy to get running with EKS is really helpful. So with this simple program, let me first actually just, to make things simple, I'm going to comment out this part and just focus in on the network for a second so we can see kind of what's going on there. And I'll save this file and I'll come over here and I'll start using the Pulumi CLI tool. And this is the way that we do deployments using Pulumi. And this is the tool that we can use to integrate into your CI and CD flows. And so I'm going to start with just a preview to see what would happen if I was to deploy this application before I'm going to actually go ahead and deploy this out to AWS. And so in this case, we see that AWS Infra network that I had in code, you can see that here. But underneath it, we can see all the other pieces that are going to get created as part of deploying that component. And so in this case, that's the standard things you would imagine, the VPC, the internet gateway, the subnets, and the route table associations. The key thing is, though, all of this stuff is very boilerplate. Whenever you're standing up a new VPC, you pretty much have to stand up exactly the same set of stuff. And people end up copying and pasting hundreds of lines of YAML files around and accidentally messing things up and spending a few hours sort of getting things working. With these components that you can create in Pulumi using software, you're able to just say new network, and you get one of these stood up and working by default. All right, so that's how we can stand up a network. If I come back over here and say and uncomment this, we'll actually see what it takes to stand up a full EKS cluster. And so I'll do that Pulumi preview again. And this time we'll see quite a few more resources to stand up this EKS cluster. And really these are the exact same resources you would see if you were to go through the Getting Started guide and click through kind of the various steps. Every single one of those steps is going to be one of these resources that you see on the screen. But we can do this without having to think about all the details of all these components. And so I'll highlight just a couple of things here. I won't go through all of this. The first is that we have this same network component that we were deploying before. And so this is exactly what we saw in that previous example. But then we see a couple of other things. Here we can create sort of the service roles associated with this, the actual EKS cluster itself, and a bunch of other supporting things. But really importantly, as well as deploying AWS resources, and we see many of those being deployed here, we can also deploy Kubernetes resources. So once the Kubernetes cluster is stood up, the EKS cluster is stood up, to actually correctly configure EKS, we have to deploy some resources into the Kubernetes cluster itself, using the Kubernetes APIs, using kubectl or some whatever other technique I might want to use. And so here we see that Pulumi lets me actually do both of those at once. So I don't have to think about going to 3 different tools and coordinating the steps I take. I can just say I want this cluster, and it will stand up both the AWS resources and the things inside the Kubernetes cluster that I need to do that. And in particular here, this is actually going to also deploy that Kubernetes dashboard into my EKS cluster. And so that's going to deploy as just a standard Kubernetes Helm chart. Okay, so that's a simple example of kind of doing infrastructure with Pulumi. The one thing I'll highlight here, I won't actually stand this up right now because it does take 10 or 12 minutes to kind of get all these pieces up with EKS. But I will just highlight one thing, which is I'll go and look at one example of one of these stacks that's already stood up. So in Pulumi, you can take a program and you can deploy as many stacks and many copies of that program as you want. So if I have this EKS cluster, I might want to deploy it in a production environment and also a staging environment. So I can stand up multiple instances of that. And here I've got an instance of this program that I stood up earlier today. And I can actually come over here and look at some of the properties of it. So I can see this is in the Pulumi dashboard. I can see that I've deployed this application, and I can see some of the configuration that I set for it. It's deployed in the Oregon region here. And I can also see all the activity. So I only did this one update. And I can actually, really importantly, see all the resources that are part of this. Oh. Not sure why we lost the, looks like we lost the internet connection here. Give it a chance to reconnect. All right, there we go. So you can see all the resources associated with this. And so these are all the different resources we saw being deployed as part of this application. But really usefully, I can actually come in here and click on these links to AWS to go directly into the resources that are under management by this program. So this IAM role that I'm using for this particular part of the application, I can dive in here and come and see exactly the details of this IAM role. But also, I can go directly to the Kubernetes resources. So you see here that because I have the service and the services associated with the dashboard deployed into my application, I can just click on these links, go into the Kubernetes dashboard, and look at those as well. Okay, so that was this example of kind of what it looks like to do core infrastructure using Pulumi. The one thing I'll quickly highlight is just some of the benefits of using code here. So one benefit is, of course, if I make mistakes, I find out about it really quickly. So in this case, if I mistyped the name of this thing, I find out about it as I'm typing my code. I get that squiggle, and I'm told I need to make a change on the fly. The same kind of benefits we get as we're doing any of our application development, but now I bring that into the infrastructure space as well. The other benefit is I can sort of see, get completion lists and find out what these things are all about. So this VPC ID, I can come in here and get help right in line for it. All the same kind of things I expect from when I'm doing my Java or C# or whatever kind of development for my application code. So that was infrastructure. Let me switch gears and talk a little bit about what it's like to do serverless and serverless with Fargate as well. Okay, so for this second example, I'm going to look at sort of a simple kind of architecture diagram that you might see if you're kind of thinking about a simple serverless sort of application. What I always find interesting is, you see, Werner or others kind of come up on stage and show these architecture diagrams, and you look at them and you're like, oh, that's a simple application, right? This application here looks pretty simple. I take a video. If it comes and I put that in a bucket, it's going to fire off a Lambda for an event trigger. That's going to run a Fargate task to do some compute based on that context, and it's going to write something back into a bucket, and then I'm going to fire off another Lambda. So I'm able to describe that whole process of what this application is trying to do in just a few words, and very easy to describe, very easy to put on a slide like this to show kind of what that architecture looks like. The reality, though, is actually turning that into a working piece of software on AWS is actually somewhat challenging. There's quite a bit of work you have to do to describe and deploy all the infrastructure you need to make this work. You have to deploy that S3 bucket, you have to stand up the Lambda and hook it up to that S3 bucket, and then you have to deploy a Fargate task and the cluster associated with that Fargate task and the task definition and all the various pieces that Tiffany demoed earlier for how you can piece together all these things to actually stand up and use Fargate in your applications. And so with Pulumi, one of our goals is to take this kind of thing and build components that folks can use that make it as easy to build this application as it looks like it should be when you look at this diagram. And so let me show you what that looks like concretely. So this is another simple example. And actually, before I jump in here, let me just highlight actually one additional thing. So this example is actually based on a blog post that was written earlier this year, I think. It was just about how to use AWS Fargate and Lambda for long-running processes in a serverless app. And so this is sort of just what is the basic way to get stood up with serverless plus Fargate and take advantage of Fargate in that kind of environment. And it's a great post and walks through this same kind of demo application. The amazing thing when we kind of look at this blog post is, it's something like 30, 35 pages of information here for how to go through and stand up this, what seems like a simple application. And it's largely because we kind of have to go through all those sort of point and click flows in the console and stand up all these different resources. And there's a lot of different moving pieces. And so really what we tried to do is take that and boil it down to its essence and say, how can we express that in a really simple way with code? And so I'll just walk through this really quickly and highlight some of the core pieces of this. So the first is, we create a bucket. We need this bucket that we're going to use to drop these images into. Then we create a Fargate task. And here we have a really simple API for doing that. So we have this cloud.task, which is just a wrapper over the notion of what a Fargate task should look like. And we can just specify some very simple configuration. We just specify the memory reservation here, 512 megabytes. And then we specify what image to build. And so because we're doing this in code and because we're doing this in a CI/CD kind of environment, we can actually specify just that I want to run some code locally. And so in this folder here, if I drop over to that folder, we see that folder just has its own Docker file. And that describes the container that I want to deploy and build as part of this application. And so this could be anything. This could be my legacy Java application. This could be a custom Python app that I've written. Or in this case, it could just be some bash script that runs an FFmpeg tool. Pulumi will actually go and build that image, push it up into an ECR repository that's been allocated on your behalf, and then hook up this Fargate task to pull from that repository and run that for you. Finally, we'll just describe that we want this bucket to, when we put a video into it, to run some code for you. And so this code will just do a couple simple things. It'll do some deserialization of the inputs. It will run a task. And then when that's all done and the Fargate task is finished, we'll actually put that into a JPEG and show it's done. So really key thing there, just in a few lines of code, we're able to express what's in that image and really make it super simple to take advantage of Fargate. So let me just quickly show the what that looks like. And I'll just, well, actually, let me just, for time's sake, I'll just quickly dive in here and show you what that stack looks like. So just like we saw that previous stack, I can come in here and I can look at the resources associated with that. And so for example, I can come in and look at the onNewVideo Lambda function or the Fargate task. I can jump over here and see the details of that directly in the AWS console. So I can see that this has been hit a couple times, and I can look at its logs in CloudWatch. One of the things, though, especially when I'm using Lambda plus Fargate, I'm trying to use CloudWatch, is there's a lot of different logs in a lot of different places. And so I really want to be able to sort of see those all in one place. And so just the one nice thing that we can do as well, because we're using both Lambda and Fargate here, we can run Pulumi logs. And because Pulumi knows all the different resources and all the different compute that's going on in this application, I can see both the logs from my Lambdas here, also from my Fargate task running here, running FFmpeg, and then finally from my Lambda at the end. So really able to aggregate all that information together and see it in one place. OK, so that's a quick tour of Pulumi. As I said, Pulumi is a programming model and development platform for the cloud that lets you do infrastructure, Kubernetes, containers, and serverless, and works great with all the container technologies on AWS.
Awesome. Thanks very much, Luke. That was great, great walkthrough. So I think with the few minutes we have left, we wanted to take 4 minutes. Tiffany, was there something you wanted to?
Yeah, so I guess it'll be easier if I just kind of show it real quick.
All right, let's hop up there and show it.
I keep doing this thing of explaining what I did wrong.
And was this from the CI and
Yeah.
CD demo?
Yep. So back with the CI/CD. So it was complaining when it was trying to push it over to ECS. The reason being, actually, there were a few things that were wrong with it. So one, I needed to put, so for my build spec, which I have over here. So one of the things is that when I was setting it up in the advanced settings, I needed to put the repository URI. For this one, I didn't make it space. It was EkoSystem. The reason that, so that's one thing, but the main reason that it actually failed is previously I had this printf for the name, which I should just change how this code works. I had the name as space, and it was looking for a container called space in the service I created, and there wasn't one since I named it EkoSystem, so therefore it failed at actually pushing it up to code build. Or, well, actually to a code pipeline. So had I actually gotten that part correct, which I don't think it's done building everything, but yeah, so basically it would pulled it down again, but like if this were to manage to have finished in time, it would be rebuilding stuff, but with the new build spec, and then it would actually end up being able to go and update the image in, it would be able to go and update the image over in ECS. But like if you take a look at least, if you look at repositories, so the thing that I had ended up trying to, like say if I had one before of like space, so you can see that it goes and has the image, well this is from earlier, so since I'd created space and had originally been pushing it there, you can see that the image tag here is space. So otherwise, yeah, it should have, like had I done that right, this would have ended up working, and it takes a little bit of time to actually run through, so you'll have to trust me that it works. And if you want to take a look at some of this stuff, if you go search up, so ECS, actually it's right here. So there's ECS Labs. There's an example. There's also a blog about it. So if you just look up like Fargate CI/CD, so there's a couple blogs, and so it has a reference architecture to continuous deployment there, and it walks through everything. And if you go back and think about CloudFormation, you can create the entire pipeline and everything you need in CloudFormation as well. So that's kind of general idea of that. So yeah.
All right, good. Thanks, Tiffany. I think it's important that we make sure when we have some things we want to show that are a better way to do it, we go ahead and do that. So we've reached the end of our time. Thanks everyone for joining on the Twitch stream, and thanks to all the great partners who joined us today and shown how their products can help customers across the entire lifecycle of containers and microservices. If you have any feedback, please feel free to email us or get in touch with us or our partners. Thanks very much, and enjoy the rest of your day.
Yeah, and if anyone has any specific like Fargate questions for me, I had previously responded to someone in the chat, if you can still see it, with my email and Twitter handles, so if you want to message either of those. So yeah.
Awesome. Have a great day, everyone. Thank you.